All right, so fatty acid synthesis. So making fatty acids. So in a liver cell, so let's just make a big giant cell here. Here's a liver cell, and inside you have the mitochondria. Here's the matrix and the inner membrane space, the inner membrane, the outer membrane there. So here's the mito. Okay. So out here's the cytoplasm. All right, and what occurs in the cytoplasm? Well, glycolysis, right? So if you have your glucose, and it's going through glycolysis. You get pyruvate. Okay, we know this. Pyruvate's the 3-carbon molecule that hops into the mitochondria. And through its little reaction, its little interim reaction thing, we get acetyl-CoA. All right. So acetyl-CoA will enter the Krebs cycle, or the citric acid cycle, and remember, it will bind with OAA. Remember, acetyl-CoA is 2 carbons, OAA is 4. And when it binds with OAA, we get citrate, which is the first intermediary there in the citric acid cycle. So citrate, which is 6 carbons. Well, when we have too much glucose or whatever, and it's time to make fatty acids, the citrate, once we get the citrate, it can go out into the cytoplasm, because acetyl-CoA can't leave the mitochondria. It can't do that. It's in there, it can't leave the mitochondria. So it has to leave as something else. Well, it turns into citrate, and there it can leave the mitochondria and go into the cytoplasm. So the cytoplasm is where fatty acids are formed. So we have citrate here, and once it's out here, a couple things can happen. We can actually get oxaloacetate and acetyl-CoA. So it can enzymatically be broken down into that and that, the oxaloacetate. Well, oxaloacetate, through a reaction that will produce NADH or NADPH, will create pyruvate. So we can go from citrate to oxaloacetate and then to pyruvate there. Okay, and we're left with acetyl-CoA. So acetyl-CoA, so this is occurring in the cytoplasm, but acetyl-CoA, through ATP, so the use of ATP, and of course we'll release a CO2, will become malonyl CoA. And from malonyl CoA, from what's produced here, from the oxaloacetate to the pyruvate, is an NAD to an NADPH. NADP. There's actually another phosphate there. So NADP to NADPH. And this little NADPH then is used in this reaction here, or this sequence of this pathway. We add in the NADPH, and we get palmitic acid. Basically, we get acetyl-CoAs coming together and forming palmitic acid. So this requires an enzyme. It's enzymatic. So the enzyme that locks these things together, that puts together these acetyl-CoAs into palmitic acid, is called acetyl-CoA carboxylase. So as long as you have the acetyl-CoA carboxylase, then we can make those fatty acids. We can make palmitic acid. All right, and that does occur in the cytoplasm. I didn't put it in here because I didn't have room, but that's what's occurring here, is that reaction there. So that is the making of fatty acids. That carboxylase, again, is rate limiting, so it doesn't last forever. It's stimulated, the activity of it is stimulated by citrate in the cytoplasm, and it's inhibited by lots of fatty acids. If there are lots of fatty acids, not really going to be wanting to make fatty acids. Okay. All right, I think that's about it for lipid stuff. And now we're going to look a little bit at protein metabolism.